Hello all. So in the last sessions we have seen how do we develop a linear regression model, right? But we didn't include performance metrics. So today in this session we'll again try to build linear regression model on the data set, but also not just building the model like what we have done in the previous session. We'll also try to predict the test results and compare the actual values with the predicted values. Okay, so this is experiment 4 as per your syllabus, wherein we say build a linear regression model using Python on the given data set by, we have to prepare the data for the machine learning model, split the data into train and test, evaluate the model. That is, when you talk about linear regression model, we have to calculate the intercept and slope for obtaining the linear regression line y is equal to mx plus c, and then we have to visualize the training data and test data using matplotlib and seaborn, predict the test result, okay, and then compare the actual values with the predicted values. Okay, so in the previous session when we were talking about developing a linear regression model, we have just built the model, right? So here we will also know the performance of the model and also apply the test data and check how well is your model performing on the test data. That is, we have to get a generalized model as like what we were talking in the previous session. Okay, the model should not be overfitting, the model should not be underfit, but you have to get a generalized model, and that thing you will know once you get to know about your accuracy. Okay, so let's start with the session. Okay, so the first step is we have to import the libraries and load the data set. Okay, so the data set that we're working here is on Boston housing data set. Okay, so as it is a regression model, I want to take the continuous values, so I'm taking a house price prediction data set. Okay, so this is the most famous data set which is available. Okay, so first let me import the libraries. Here I'm importing NumPy, I am importing pandas, and from sklearn.model select I have to do the train test split, and this particular function is available in this module which is called as from sklearn.model underscore selection I will import train test split, and then I want to implement linear regression model, and the function is available in sklearn library in the path sklearn.linear underscore model. We have to import linear regression. Now as I told you, we are not just developing the model, but we are also evaluating the model and predicting the results. Okay, for evaluating the model we have seen different types of metrics, right? For regression we have MSE, mean square error, mean absolute error, root mean square error. So from sklearn.metrics I am importing mean squared error, mean absolute error. You can choose only one. For showing it to you, I have chosen both. Okay, so I am importing the metrics mean squared error, mean absolute error, and I'm also importing matplotlib.pyplot to visualize my graph. I'm also importing seaborn for more visualization and more understanding. Okay, so NumPy for numerical operation, pandas for reading data set, sklearn library for working on with different operations like train test split, to import the linear regression machine learning model, and then metrics are also available in sklearn for train test splitting, for model development, and then for metrics we will use sklearn. Okay, now there are different ways in which you can load the data set. Okay, so you can directly give the path of the web link where the data set is available. That is what I have done here. So the URL I have taken it from GitHub from somebody's random account. Okay, so in GitHub Selva 86 accounts in datasets master, I have this Boston housing dataset. I'm just directly copy pasting that particular URL, and I'm trying to read that using pandas. Okay, so I have taken a variable called data, and in that data using pandas library I am reading this particular URL. Okay, and I want to check what that dataset is all about, so I'll print the head, that is the first few rows of that dataset would be printed. This would be the output. Okay, so I have different parameters here explaining about the house price. Okay, so I have CRIM, I have ZN, Indus, case, NOx, RM, age, display, tax amount, PT ratio. There are so many different parameters. I don't want to work on many of them. So what I do is, for developing my model, I'll simply choose, as I'm going for a linear regression model, I'll choose only one input variable and one output variable, and let's see what did I choose here. Okay, so I want to prepare the data for modeling. So from this particular data set, okay, MADV is nothing but the output variable that I want to take, and RM is the input variable that I want to take. This is not multiple linear regression. I am developing a simple linear regression which requires only one input variable and one output variable. Okay, so from this you have to understand that the data set may be available in any format. Depending upon what model you have to develop, you have to load the data in that particular way. So here in this case I have a huge data set. But when I want to build a simple linear regression model, I want only one input variable and one output variable. So for that reason, I'll prepare my data for modeling. So the data set contains various columns, out of which MEDV, which is median value of owner occupied homes, okay, as the target variable, that is the output. MEDV as the output variable. So I say from this data that you have, okay, I want to take MEDE as my output variable and RM as my input variable. RM is nothing but average number of rooms per dwelling, okay. So here I am trying to predict the price of the house based on rooms. That makes sense, right? 2 BHK. See, here also we use that. 2 BHK, the cost is this. 3 BHK, the cost is this. Villa, the cost is this. 5 BHK, the cost is this. Independent house. So, depending upon the number of bedrooms, we have the cost estimated for the house. So, for that reason, I am taking average number of rooms as the input feature, median value of the owner occupied home in dollars as the output variable, okay. Rooms as input, price in dollars as the output variable. So this is how I prepare the data for the machine learning model. Now after that, I want to split my data into train test. So I have taken RM to be my input, MADV to be my output, right? So let's say I have 6 different values. Let us assume. Okay, so I have 1, 2, 3, 4, 5, 6 values of different RM. I say, so when I take RM as my input and MEDV as my output variables here, I am taking 6 values. So when I talk about train and test data, I have divided this data into training and test. Okay, so this is my input X, this is my output Y. Okay, now this is my training data and this is my test data. So I say for 3 bedrooms it is $1,000. Okay, so for here it is $1,005. Here I say it is $1,200. Here I say $1,210. Here I say $1,300. Here I say $800. Okay, so this is my X and Y. Okay, so I will divide this entire 6 data into train and test. Okay, 80%, 20%, 70% or 30%. Training data should be more and test data should be less. Okay, now this is X and these values are called as X train. Okay, these values are called as Y train. These two values are called as X test. These two values are called as Y test. Okay, this is X train, Y train. This is X test, Y test. What we do is, when we are training the model, we give both X train and Y train and train the model. We give both X train, Y train and train the model. When we are testing the model, we hide these values. We hide these values, we will give this input and ask the model what is the output. Okay, now I call this as Y prediction. Y test is the known value, but what we do is, we train the model with X train, Y train. Okay, while testing, we give X test, we hide Y test and ask the model what is Y prediction. Okay, and then we will compare the result of Y test with Y prediction. Okay, what are the actual values, what are the machine predicted values. Okay, so for this reason, we split the data into X train, this is X train, X test, Y train, Y test. Okay, so here the test size is 0.2, that is 20% of the data is taken for test, remaining 80% is taken for training. Okay, now after we are done with train test splitting, we will develop the model. Okay, or we train and evaluate the model. Okay, so I am using the model linear regression, in which I am fitting the model with X train and Y train. As I told you, we fit the model or train the model with X train and Y train. Okay, I am fitting the model with X train, Y train, and I am trying to calculate the intercept and slope of that particular model. So this is the intercept and this is the slope of the model. Now I am done with developing the model, okay, or designing or training and evaluating the model. Once I am done with this, I'll try to evaluate and compare the results. Okay, so for evaluating, I want to visualize both training data and test data. So I am taking a subplot where I am taking 1 row 2 columns. First figure is training data, 1 row 2 column test size is test figure is second. Okay, in the first figure I want training data, in the second figure I want test data. Okay, so I'm using different color codings here. I'm using blue color for training data, red color for testing data. Here the label that I'm giving is regression line, that is training data, regression line for the test data. So here the input label X is number of rooms, that is RM, Y label is number of median value of homes. Same case I am doing it here. Okay, now when you look into this particular graph or the output here, this is your training data, this is your test data. Okay, the model is underfitted here. Okay, as you can see the model is underfitted because it is giving a simple linear regression line. Okay, so median value of the home, this is the output, this is the input, these are the data points and the linear regression line is being covered like this. This is on training data and that is on test data. The training data itself, the model is not performing well because as you can see the distance between this is the actual value, this is the predicted line. Okay, so the distance between actual value and predicted value is large. Only for few points here it is okay, but when you look into these points, when you look into these points, there, see, this is the actual point, this is the predicted point. So the difference between this is very huge. So I say it is an underfitted model because the model is not generalized well. Okay, I have huge difference between my predicted values and actual values. Okay, now when you look into this, I also want to predict the results. As I told you, I have trained the model. We have trained the model on X train and Y train, and I want to go for Y prediction based on X test. Okay, so for which, as you can see here in this next block of code, I want to predict Y prediction based on X test. I know what is Y test. Okay, but I don't want to know what is Y test. I want my model to predict my Y output for the X test data. Okay, now when you see this particular thing, you see what am I trying to do here? I am trying to plot Y test and Y prediction. Okay, for mean squared error. For mean absolute error also I want to plot Y test and Y prediction. That is, I want to see what is MSE and MAE. Okay, difference between actual output and predicted output is MSE and MAE, as we have already studied. Okay, the difference between actual values and predicted values. When you look into this figure, these blue dots are nothing but the actual values. These are the predicted values. This is the actual value, this is the predicted value for this point. This is the actual value, this is the predicted value. Actual value, predicted value. So this difference is nothing but MSE. Okay, what is MSE? Summation of, we do go for summation of I is equal to 1 to summation of I is equal to 1 to n y minus y cap whole square. Why am I doing square? Because sometimes the value may be below this or above this. Why am I going for summation? Because I want to consider the average error of all the data points which are available. So I want to calculate mean square error, mean absolute error of what? Actual value and predicted value. What is actual value? Y test. What is the predicted value? Y prediction. As you can see, the actual value is 23.6, the predicted value is 23.7. Actual value for one data point 32.4, predicted is this much, actual is this much, predicted is this much. Okay, so as you can see, sometimes predicted value may be more than that, sometimes the predicted value may be less than that. Okay, so the error is 46 error. Okay, that is 50% of the data points are having errors. That is the reason I have said it is an underfitted model. Okay, so this is how we actually develop a linear regression model. Okay, so let me quickly recap it once again. We will first import the libraries and load the data set. We will prepare the data for modeling. Choose your input parameters and output labels properly here when you prepare for the data, and then divide the data into training and testing. As I told you, we train the model with X train and Y train. When you are testing, we take X test and try to predict Y prediction, and then compare Y test with Y predictions. Okay, and then we evaluate the model. For training, we fit the data with X train, Y train and calculate the intercept and slope, and after that we do visualizations for training data, for test data, which will actually give you the difference between the original data point and the predicted data point, and then finally we are calculating the test results for predictions by calculating mean square error and mean absolute error. Okay, so this is all about how do we develop a linear regression model, and how do we visualize training data, test data, and how do we apply performance metrics like MSE and MAE and get to know the accuracy of the model. Okay, thank you so much.